So this is my fourth and final video lesson for the unit measurement. Today we're going to talk about determining and calculating significant figures. Let's go to page 14 in the class packet. Motivation. What is the approximate length of the metal bar? So here we have two rulers. So A, if you got it, it'll be 16.3. B will be at 16.25. Which one is more precise? How do you know? B is more precise. Notice we have an extra digit, right? And you notice in the ruler it has more lines. Learning target. At the end of the lesson, I'll be able to determine and calculate significant figures. For announcements, homework number 4 will be based off of this PowerPoint. There will be a quiz on JunoPod, which will be PowerPoints 1 to 4. The exam will comprise of Unit 1 and Unit 2. What are significant figures? Let's read this passage. When reporting values that were a result of a measurement or calculated using measured values, it is important to have a way to indicate the certainty of your measurements. This is accomplished through the use of significant figures. Significant figures are the digits in the value that are known with some degrees of confidence. As the number of significant figures increase, the more certain the measurement. Question 1. Do significant figures relate to accuracy or precision? Since significant figures is basically the digits, it relates to precision, right? This is what we discussed in the previous PowerPoint. Let's explain this further. This is a triple beam balance. We use this in lab, right, to measure the mass of something, for example, this apple. You may notice that the beams had a set amount of lines, which is the intervals. So the more intervals you have, the more significant figures you have, right? So even though your measurement may have a lot of digits or significant figures, it does not mean your measurement is accurate, right? So for those who used the triple beam balance before, you typically have to adjust or calibrate your instrument before using it. If your instrument is not calibrated, then it will give you an inaccurate measurement. It doesn't matter how many significant figures you have, okay? So let's go over the 5 rules for determining significant figures. Rule number 1, all non-zero digits are significant. Let's look at this example here. The non-zero digits are 5, 8, and 3. They are significant. Let's do 2 more examples. If you have a number, 549, that is 3 sig figs. If you have another number, 1.892, that is 4 sig figs. Let's look at rule number 2 now. All zeros between non-zero digits are significant. So if you look at this example here, this 0 is between these non-zero digits. Therefore, it is significant. Let's look at some examples. 4.023 has 4 significant figures. This 0 is a between 0. It counts. 50014 has 5 significant figures. These 2 zeros count. Rule number 3. Leading zeros are zeros to the left of the first non-zero digits. So if we look at this example, it is these zeros here. They are not significant. They don't count. So let's look at some examples. If you have 0.000034, it only has 2 sig figs. These zeros are leading zeros. They don't count. You can see this if you write the scientific notation, 3.4 times 10 to the negative 5. This number, 0.001111, has 4 significant figures. These leading zeros are not significant. Learning check number 1. How many significant figures is 11254 cm? Try this yourself, pause the video, and resume once you have the answer. So since these are all non-zero digits, they are all significant. So it's 5, choice 1. How many significant figures is 1003 milliliters? Pause the video and resume once you have the answer. Since these zeros are between, they are significant. So therefore, there are 4 significant figures, choice 3. How many significant figures is 0068 liters? Pause the video and resume once you have the answer. So the answer is choice 1, 2 Sig Figs, because these two zeros are leading zeros. They are not significant. How many significant figures is 0.002 meters? Pause the video, resume once you have the answer. So the answer is choice 4, 1. These leading zeros are not significant. Okay, let's continue. So rule number 4, trailing zeros. They are zeros to the right of the last non-zero digits. So if we look over here, these are trailing zeros. They are significant when there is a decimal point in the number. Notice there's a decimal point here. Therefore, these zeros are significant. So if you have 400 with a decimal place, that is 3 significant figures. If you have 2.50, that is 3 significant figures. 0.050 has 2 significant figures. It's this zero here, which is a trailing zero, that is significant, not these two leading zeros. 3.7770 is 5 significant figures. This trailing zero is significant. The last rule, trailing zeros are not significant in numbers without decimal points. For example, 470000 has only 2 significant figures, right? These trailing zeros are not significant. If you compare this one with this one over here, this has 3, this one only has 1 without the decimal place, right? You can see it better if you write the scientific notation. Okay, so for practice number 1, I want you to indicate the number of significant figures. So pause the video, try to do it yourself, resume once you have the answer. Okay, so here are the answers. Why do we keep track of significant figures anyway? So you can read this on your own. If you were paying attention to this and the last video lesson, I think you have a good idea of why do we do it. Task number 2, calculations involving significant figures. So let's start with addition and subtraction because they have the same rule. When adding and subtracting numbers, the answer has the same number of decimal places as the number in the calculation with the fewest number of decimal places. Round off your answer. So let's do an example of what this means. So when you're adding, the significant figures of your final answer depends on your decimal place, okay? So here we have 34.34 plus 2.6 plus 1.341. That gives you this on the calculator. But we want to put the final answer with the smallest amount of decimal places, which is based off your numbers you're adding with. So if you look at 2.6, it has the fewest number of decimal places. It has 1 decimal place. So your final answer must have 1 decimal place. So you round this answer to 1 decimal place. So for addition and subtraction, it depends on the fewest number of decimal places. Let's do a learning check. Expressed to the correct number of significant figures, the sum of two masses is 445.2 grams. Which two masses produces this answer? So try this yourself, pause the video, and resume once you have the answer. Okay, so the answer is 3. Since this is addition, because this is sum, you're looking for one with 1 decimal place. So 3 is the only one with 1 decimal place. The other one has more than 1 decimal place. So now we're going to go over the rule for multiplying and dividing numbers, since they have the same rule. The answer has the same number of significant figures as the number in the calculation with the fewest number of significant figures. Notice this is different from addition and subtraction, which deals with decimal places. This one just deals with significant figures. Again, round off. So let's do an example. if we have 6.24 meters times 4.3 meters, if you plug this to your calculator, you get 26.832 meters squared. If you notice, the first number has 3 sig figs and the second number has 2 sig figs. Since the second number has the least amount of significant figures, our final answer must have 2 sig figs. Okay, so you round the 26.832 to 2 significant figures. That's where we get 27 meters squared. Learning check number 6. What is the product of 2.324 cm times 1.11 cm expressed to the correct number of significant figures? So try to do this yourself, pause the video, and resume once you have the answer. Okay, so the answer is 1. So you first plug this to your calculator. You notice this one has 4 sig figs, this one has 3 sig figs. So your final answer must have 3. So you can even do this without even using the calculator. You just need to count the number of significant figures. In this practice, I want you to solve the following from A to K using the significant figures rules. But before you do that, I want to show you a significant figures calculator on my website. This is my website. So go to Unit 2, scroll down to the significant figure calculator. This calculator can count the number of significant figures for numbers and expressions. If you see a number that you're not sure what's the number of significant figures, you just type into the calculator, for example, 6.090. Notice it tells you the number of significant figures and the decimal places. You can also write an expression, for example, plus 1.03. It tells you the answer, 7.12, the number of significant figures of your answer, and the steps on how to solve for it. For multiplication, you have to use the star, and for division, you have to use the slash. I recommend that you use this calculator to check your answer when you do the practice. Take a moment to complete this practice. Resume the video once you're done. Okay, so here are the answers from A to K. Notice I included units in all my answers, so make sure you do that on the exam and on the regions. On the regions, you only need to include significant figures in your answer only if the question says so. So this concludes the video lesson for today. Remember to do the Junipod homework and quiz, and there'll be an exam based off Unit 1 and Unit 2. In the next lesson, we will be starting Unit 3, Atomic Theory.